Right. Welcome, GeoTrig. This is section 2-2, conditional statements. The essential question is, what can you do with an if-then statement? And let's begin. So I think this is a weird chapter, but it's kind of cool. So I looked through this, and I think I know what's really important, so follow along. An if-then statement is a conditional. Now, the book will say this differently. It says conditionals are if-then statements. But I don't think that's true because conditional, especially when you're talking about computer programming, there's all different types of conditionals. Do while loops and for loops. I don't want to say it as a conditional as an if-then. But the focus here is these if-then statements. So if something, then something else. That's what's going on. And the two parts of this are the hypothesis and the conclusion. The hypothesis follows the if part, and sometimes it's labeled the P. And the conclusion follows the then part, which we sometimes label the Q. So if P, then Q. So for example, if an animal is a robin, then that animal is a bird, because robins are a type of birds. If an angle measures 130, then the angle is obtuse, because all obtuse angles are more than 90 degrees. So let's practice rewriting a conditional. I have a sentence right here. Vertical angles share a vertex. So we want to write it as if blah, then blah. So what are our two blahs here? Well, vertical angles share a vertex. We can say if angles are vertical angles, then they share a vertex. So we say they share a vertex. So if angles are vertical angles, then they have to share a vertex, because that's those angles that are back to back. So that's true. Conditionals can be false. So, and then we want to find a counterexample. So let's look at these two conditionals. They aren't truths that always have to be true. They could be a conditional that someone says, and just because they say something doesn't make it true. So in these cases, we want to find counterexamples. So if a woman is Hungarian, then she is European. Is this true or false? Well, this is actually true. Because if you're Hungarian, then you are from Europe, so therefore you are European. So that is definitely true. Let's look at the next one. If a number is divisible by 3, then it is odd. Now, this one is definitely false. So it is false, so we want to get a counterexample. If a number is divisible by 3, then it is odd. Well, 12 is divisible by 3. Because 12 divided by 3 is 4, but 12 is definitely not odd. So that's one example. All right, I think this is the coolest part right here. We're talking about negation, the opposite of a statement. So one way to label negation when we talk about opposite of a statement is put this tilde in front of it. So we got a tilde P or tilde Q. Now, this table right here, we have a conditional, converse, inverse, and contrapositive. So those are, I don't know if those words are really important, but it's the concept behind it. So we have this if-then concept, if P then Q. Well, we can take those conditionals and we can rearrange them to use as proofs. And this is what you'll be doing when we're proving things in future chapters. You'll be given some kind of conditional, but you'll have to use that as part of some proof. But you might just rearrange this some way to use it in other ways. So we might say if P then Q. Well, we have something called the converse. We could just reverse those. If Q, then P. And then we have something called the inverse, which means instead of P, if P, then Q, we do if not P, then not Q. And then we can do the contrapositive, which is basically flipping it and then making it the not. So if not Q, then not P. Those are a lot of craziness here. Let's actually do a real example and see what this looks like. So this is that same chart with those four words, our conditional, our converse, inverse, and contrapositive. So our conditional statement, and this is what I'm going to call the given statement, okay? This is something that you're probably given, some conditional. If the measure of angle A equals 15, then angle A is acute. And let's make this table, and we're going to ask, is this true or false? Is this true or false? So it's true or false. So if the measure of angle 15 equals 15, then angle A is acute. Well, that's definitely true, because all acute angles are less than 90 degrees, and this is less than 90 degrees. Now, converse of this. If angle A is acute, then the measure of angle A is 15 degrees. This is false, because acute angles don't have to be 50 degrees. they can be as long as they're less than 90, they're between 0 and 90, they could be like 80 degrees. So that could be an example. So this statement, this is a conditional, and it's the converse of the conditional, but it's a false statement. We can't use that. Just because this conditional is true doesn't make the converse true. Let's talk about inverse. So if the measure of angle A is not 15, then angle A is not acute. Well, again, this is false, because what if you had the angle 80 degrees? This is a acute angle, but this is definitely not 15 degrees, but it is acute. It is not acute, it is acute. So this is false. This doesn't work. Contrapositive. If angle A is not acute, then the measure of angle A is not equal 15. This is true. Because it's not acute, well, that means it's either a right angle, it is a straight angle, 180 degrees, or it is an obtuse angle, and that's going to be greater than 90 degrees. Then all of those conditions, 90, 180, and bigger than 90, they are all not equal to 15. This does not fall into there, so this is true. So it's different ways of rearranging our conditional, but they don't all, just because the conditional is true, doesn't mean they're all the others are true. You got to think logically. So let's try this example. Pause the video. All right. What are the converse, inverse, and contrapositive of the conditional? Are they true or false? If false, give a counterexample. So just do what I just did on the notes. If the figure is a square, then the figure is a quadrilateral. This is our conditional, and this is true. Because if something's a square, it's a quadrilateral. Converse is flipping that. So I'll write this in shorthand. If figure is a quadrilateral, if figure is a quad, I'm just going to abbreviate, then fig is a square. And I'm abbreviating. You can too in your notes if you know what they mean, as long as you're consistent on that. So if figure is a quadrilateral, then is a square? Well, that's not true. That's false. Because you can have quadrilaterals that are not a square, and one example of that could be like a rectangle. So you can draw a rectangle, and a rectangle is a quadrilateral because there's 4 sides, 1, 2, 3, 4, but it is not a square. So there's your counterexample. Inverse. So that means you're doing the not of these things. So we say if figure is not a square, figure is not a square, then the figure is not a quadrilateral. Then the figure is not a quad. So if a figure is not a square, then it is not a quadrilateral. Well, no, that has got to be false. Because we can, again, make that rectangle here. It's the same thing. This is not a square, check. But it is a quadrilateral because there are 4 sides, 1, 2, 3, 4. So there's your counterexample. It's a rectangle. Now, contrapositive. This is where you're taking the converse, basically, and making them the knots. So if a figure is not a quad, quadrilateral, then that figure is not a square. The figure is not a square. Well, is that true? Yeah, that's true. Because if it's not a quadrilateral, okay, so then it has like 3 or less sides or 5 or more sides. Then the figure is not a square. Well, yeah, because a square has to have 4 sides. So this has got to be true. If it's not a quadrilateral, it can't have 4 sides, and that's one of the parts of a square. You have to have 4 even sides. There have to be 4 sides. So that is true. Try the last one. So pause the video. All right, let's go. Same thing here. So the conditional is if a figure is a rectangle with sides of 2 centimeters and 3, then it has a perimeter of 10 centimeters. And that's true because we'll just draw the picture just to help me out. So remember, we got a 2 and a 2 and a 3 and a 3 sides. So all those add up to 10. So that is true. Okay, so the converse. If it has a perimeter of 10, then the figure is a rectangle with sides of 2 centimeters and 3. So if a figure has perimeter, I'm going to say big P equals 10 centimeters, then it is a rectangle. I believe as rect with sides 2 centimeters and 3 centimeters. Okay, well that's not true because you can have any sided figure and the sides. We could make a triangle. We could have a sides of like that add up to 10 centimeters. It could be 5, 2, and 3. And these could add up to well, no, that wouldn't work. But you could have a triangle. You could have any other shape and the perimeter adds up to 10 centimeters. Oh, we got to do a counterexample. So, let's do one. So, just any sort of polygon. It could be a rhombus. So, let's do a rhombus. So, all the sides are the same, and all sides are going to be 2.5 centimeters. And there's 4 sides. They add up to 10, but they're not a rectangle. And those sides are all 2.5. They're not 2 and 3. So, this is false. The inverse, so it's the not. If a figure is not a rectangle, so if a figure is not a rectangle with sides 2 and 3, then it does not have a perimeter. Then it does not have a perimeter that equals 10 centimeters. Okay, so what does that mean? If a figure is not a rectangle, so a figure is something else besides that, then it does not have a perimeter. Well, this is false because it could have some kind of thing, and this goes back to that rhombus again. That's kind of neat how that works out. So a figure is a rectangle, is not a rectangle with sides 2 and 3, so that could be the rhombus, and it does not have a perimeter. Well, the rhombus does. So that is false. So the last one, we're doing the knots of the converse, right? If the figure does not, so if figure does not have a perimeter of 10 centimeters, then it is not a rectangle. Not a rectangle with 2 and 3. And is that true? Well, if it does not have a perimeter, if a figure does not have a perimeter of 10 centimeters, it is not a rectangle with 2 and 3. That is true. Because in this case, a rectangle with sides 2 and 3 centimeters, it will have to have a perimeter of 10 centimeters. There's no way it can't. So that must be true. All right. That's it.